to see my students. I look forward to our sessions together, you guys, so appreciate your patience.
Okay, so I started recording. I am muting myself out. Thank you.
Thank you so much.
Have a great session.
Thanks. So, okay, you guys, so you guys are learning about the rectangular coordinate system, and let me get the questions little window up, and let's see if I can expand it. So, have you guys begun really looking at lecture 6 and the rectangular coordinate system? Have you guys looked at that? How is it going? Are you guys understanding it? Is there any point where, I'm going to ask y'all this too, as you're covering it, what is the point, like as you progress, what gets you confused? Like what stops you in this topic? Because we're looking at linear equations. So that's kind of what I want to know from you guys. What really gets you? Or when you go back to check your work, what are you getting confused with? Or what point, you know, when do you take that fork in the road on the wrong direction, you know? So I want to know about that. So think about that while I'm talking about this. And so maybe you guys can put some questions in. Don't be afraid. Don't be ashamed. Most of you guys, if you're having trouble with something or having the same issues, so it'll help, you know. Okay, so excuse me. So far, we've looked at equations in one variable. Okay, you've seen linear equations in one variable, and you had to solve, right? We've had to solve equations with just an x, right? With one unknown, right? In one variable. All right? One variable. And what did our solution look like? Okay. So we had like x equal to something, right? We would have x equal to a, and a is just some real number. Okay. And the solution was on, we could look at it graphically on the number line, okay? And let's just say a is just some arbitrary number here, okay? And so a was just a point, right? It was a single number, right? But what the area was that we graphed it on was a one-dimensional line. What we're having here now, we're going to be trying to solve equations now. These are our linear equations, right? And I'll talk about that, the word linear, in a sec. Now we're solving equations when we say in two variables. And now we have the x and the y. Now, as we progress with this, you guys, we keep it in alphabetical order for one thing. Okay, so the solution looks like this. So here was the solution for the one variable. So the solution for these new ones now with the x and the y, of course, as you know now, if you've kind of done a little bit of the work, looks like that, x and y, okay? And of course, I'm going to say where x and y are both elements of the real numbers, okay? They're both real numbers. And now instead of just that one number, that single solution, we'll call this just x, right? Now we have two-dimensional solutions, right? We have two solutions to consider. So the horizontal axis is the x-axis, right? So the first one I drew here is called the x-axis. Keep it in alphabetical order. You won't, it'll help you. And the way you can remember that this is the x-axis is x comes first in alphabetical order, and horizontal axis is what we looked at before when we had a single solution with the number line. Okay, and then the vertical axis, which is the new thing. Okay, so now we have this added axis, right, the y-axis. Okay, and so now we have this, okay. So what do the solutions look like? Okay, well, xy is just a single solution to these equations. If you wanted to make a set of all the solutions of a linear equation in two variables, it would look like this most of the time, okay? So 99.9% of the time, for your purposes, here's what your solution set will look like graphically. And what happens here, let's pick a little area, a little point here. Here's a point on that line, right? And let's call it X, Y. Okay, and for those of you who are not sure where I'm drawing on the screen, I'm here. Okay. So this point, X, Y, is a solution. It's one out of infinitely many solutions. Any point we can choose from this line, any point down here, 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 wherever there's a point, it will make a true statement. So, for example, if I have this X example, see, let's have this line, Y is equal to just X. Simple, simple line. This is just a diagonal. Kind of close to what I drew there, but not quite. So let me kind of erase the little thing I drew there. I'm going to go back up to where my main drawings are I prepared for this time together. Y is equal to X. Okay, that's pretty simple, and I'm going to go into this chart I'm making here in a bit. Let's say, okay, well, if X is 0, then Y has to be 0. If X is 1, Y has to be 1, right? And this is this little XY chart, okay? All right, and let's say if X is -2, Y has to be -2. Okay, and I know I haven't taught you guys to plot points. I'm thinking y'all probably know how. If you will get a good review as I go along, like right now, starting now. Okay, so here's my X-axis, and here's my Y-axis. My lines weren't perfect, but that should be good for this minute, for right now. So let's start by plotting the point 0, 0, which, by the way, is also called the origin. Okay, the point 0, 0 is called the origin. And a good reason for you to remember that name, origin, okay, by the way, it's at the center of the graph, right? Okay. If we're looking at just X as a number line, okay, do this. Now look at it as our old school number line that we're used to seeing. Okay, let's pretend we did this 0, and then we had 1, -1, -2, etc., etc. Okay, then 0, which is our X coordinate, right? Okay, we're looking at the point 0, 0. Remember, that's X, comma, Y. Okay, so here is the 0. We start here at the center. And so the X coordinate tells us left or right, the direction of the X-axis, which direction to go. Okay, and if it's a positive number, we go to the right towards the positives. If it's negative, we go left. Then from wherever we end up, we take the up and down. We take the Y directions. It's like reading a map. Okay, and each coordinate is a leg of the journey. Okay, so now we're at 0. We didn't move left or right, so we're here at the origin. We go 0 up and down, so we end up here. That's where we end up. Every time you plot a point, you start here at the origin. Always start here. Okay, so this is always your starting point, okay? Okay, to plot points. Any point. Okay, and that might seem like an elementary idea, but I've had students who can do everything else in this skill set, and then they forget to start at the origin. Let's plot the point 1, 1. So this is the point. I'm going to go ahead and use that 0 I drew there. 0, 0, right? So to plot the point 1, 1, we're going to go back up and plot a bunch of points today, so fear not. Okay, so we start here at the origin. We move 1 to the right. Okay, so let's let me change my color here. So to plot the point 1, 1, X is telling me to go 1 to the right, right? 1 to the right, and then the Y coordinate tells me up and down vertically where to move. Positive 1, 1 up. That's supposed to be an arrow. Arrow, arrow. So we end up here, right? This is where we wind up. Okay. Okay, so there's that one. Let's do -2, -2. Okay, so we start at the origin. Okay, so let's see. Let me come here. This is point 1, 1. I label my points too. When you start getting a little better at the graphing thing, you know, labeling the line will be more important than each point you plot. But okay, that wasn't supposed to happen there. Okay. So now we're going to start at the origin, and we're going to move in the -2 left to right direction. Okay. Let me get my bearings here. Okay, so I'm here at the origin, all right, and I'm going to move 2 to the left, right? 1, 2. Okay, so that's the -2. And then I'm going to move -2 direction, which would be 2 down, right? So let me put that here. And so let's see, here and here. So this is where we end up. We end up right here in this lower area here, and I'm going to get into which each area is called. So this is the point -2, -2. All right, and I'm not going to stay in this topic that's this super elementary right now. I'm going to kind of go on to some good stuff, but this is just to kind of give you for the example's sake here. Okay, so the point I have plotted here is, excuse me, the line that I've drawn here. Okay, this line is the line, and here's how you label it at the end of your line that you draw. Right here, you label it with the equation. Okay, so this is every point I can pick. Now I can go along this line and pick any point, and what will happen is if I would plug it into this equation, it would make a true statement. For example, let's test -2, -2. If you plug in -2 equal to -2, of course it's going to say true statement. So it is a solution. It checks out. Let's try plugging in 5, 0, where x is 5. That would be on the right, right? And y is 0. Is that true? False, right? This is a good example to kind of show you. So this is not a solution. Not a solution of y equal to x. Something else maybe, but not this one. Okay, so anyway, the point is the solutions are ordered pairs or coordinates, x and y. Okay, now how are you guys so far with the rudimentary things? We need to go over quadrants. Do you guys need to see that? I'm looking at your hands here. Okay. Do we need to look at quadrants and the basics? Do you guys need to practice some basic things? Okay, no, not really then. Okay, good. So just to review then, let's just look at this, and I'm going to make this quick. So our rectangular coordinate system is broken up into 4. When you draw your axes, the big giant plus sign, it breaks it up into 4 areas, okay? So we have the first quadrant here, okay? And note that in quadrant 1, your signs of your coordinates are both positive, okay? Okay, and then you have quadrant 2 right here. Notice the signs. You have to go from the origin, you have to move left and then up, right? So negative, positive. So negative direction, and then up is positive direction for the y, right? So negative, positive. This would be the signs on your coordinates. Okay? And then if we go around counterclockwise, the next thing you go to would be the third quadrant, quadrant 3. Notice you have to move negative direction, right? So both signs on both coordinates would be negative. Okay? Now, then you go around to quadrant 4, and then you have what? Positive direction, negative direction, right? Positive, negative. So kind of keep in mind the movement. Each coordinate gives you a direction to go in, and then how many steps to take. It's kind of like the pirate's map. Paces, take 3 paces towards the south, you know. For example, let's take a look at A. Let's just plot this point, negative 4, 1. Okay? So let me give you a better highlight of that. So I'm looking at A, negative 4, 1, for example. Okay? I'm going to plot it on this area to the right. Okay? So the 4 tells us what? X direction, right? Let me label my axes, X and Y. So this 4 is negative, so it tells us from the origin I need to go 4 paces to the left, right? 1, 2, 3, 4. And we end up here, right? I'm just putting little dots around it. I don't want to make a point out of that. Okay, from here, then the positive one tells me to move upward 1. So we do end up right here. Okay, so this is where you draw your point, wherever you end up. Remember, you go X left to right, then up and down. Always in that order. Do not sway, don't go away from that order. It will mess it up. It won't be right. If I would swap them out, 1, negative 4 would be in totally the wrong quadrant. Okay, so this is the point, negative 4, positive 1. Okay. Oftentimes, when students are plotting, they get a little confused with the zeros getting thrown in there here and there. Let's look at C, 0, negative 3. When you have a 0 there, you're going to always start at the origin, right? That 0 on C is just saying, how many do I move left to right? Well, in this case, 0. Okay, so we don't go anywhere left to right. And then, so after that, we only move down 3, right? Okay, so then it's the point you plot will be actually on the axis. So we go 1, 2, 3. Okay, so we're here. So this is the point 0, negative 3. Okay? Okay, and so I think we got it. We're going to plot plenty of points today in our as I do some examples with y'all. So I'm looking in the questions. I'm not going to refresh it or anything, but if y'all have any questions or any example you would like for me to look at, I can do that. Okay. So, okay, let's go to an example. Let's go down here. Let me get my little notes. Where's my notes? Okay. Here we go. Okay, let's take a look at what exactly are we going to be asked to do. Okay. So let me move this downward. Okay. Oh gosh, a lot of traffic today. Okay. Okay, there you go. I'm trying to hide the GoToWebinar thing. All right. Excuse me. Here is, let's see, oh, got it. Okay, I'm trying to get my little examples up. Okay, so here we are. All right. So let's take a look at how to kind of verify. You were asked in the, earlier this, weeks ago, how to verify that x equal whatever is a solution to this equation. So this is something you may be asked to do, and that's kind of what I was doing here in this example that you see here. Like when I did that, I was verifying to see if 5, 0 was the solution, and it did not verify, did it? It actually came out to a false statement. And so, we could not say that it was the solution. So this is something we want to do right now. Let's see. I'm trying to add some space. All right, and it's not cooperating. Okay, here we go. So let's try that. Let's do an example quickly. Okay, so I want you guys to verify, and I'm just going to do 1 or 2 of these points or solutions of negative 2x plus y is equal to 2. Okay, so let's say A, I'll just do 2 of these. A, let's see, 0, 2, and B, let's have negative 1, 4. Okay, so let's try these, okay, and let's verify. So remember that you have x and y coordinates, okay? So this is x, and this is y. X, y. So we want to kind of just remember that. Okay, so we're going to write down, this is when that template style of my equations, when I write them out and I open just a set of parentheses where I'm going to plug something in, is very important. Because when you start dealing with more negative, positive, negative values, and then more than one variable, it can get a little tedious, but so you guys have to be very careful with that. So notice what I have here. This is my template. This is basically my template, okay, and I can write this down for both of these problems, right, what I have here so far, okay, and so I'll just go ahead and do that. I'm going to do that right here too, -2. It's just my equation with nothing in place of x and y, and I'm going to go back and put those values in, okay, that's your template. So let's try A. Plug in for x 0, where there's an x, put a 0. Okay. All right, and then where there's y, we're going to put a 2. All right, so what happens here? This is -2 times 0, which is just 0. Okay, plus 2 is equal to 2. That's easy, so 2 is equal to 2. All right, so true statement, it's going to be a solution. Okay. After this example, by the way, we're going to go straight into graphing and looking at slope, and we're going to do it kind of quickly. In part B, we're going to do this. Let's do -1, 4. We should be good and warmed up now. This is good. We should come stand. I'm going to have to tell them to come back. -2 times -1. This would be +2 plus 4. Okay, and bring down the equal to 2. Equal to 2. Is this going to be a true or false statement? So is this going to work out? Is it a solution? No, right? Since it's false, and I'm going to keep it in the red just to kind of call your attention, since it's a false statement, and we don't want to try to make it look like anything, you have to let the chips land where they fall, right? So false means what? Not a solution. I'll just leave it at that for now. Okay. So let's move right along, okay? All right, so yeah, if you have a question or something, please do raise your hand. I'm keeping my eyes, kind of glancing over there every now and then, okay? Okay, all right. So let me get this, I have my examples from the book here, so let me get this up. Let me move that up here. Come on. There we go. Here it is, chapter 4. Okay. Excuse me. Okay, let's see. There we are. Okay, so let's kind of take a look at the format of a line. Okay, there's different ways you can write a line. Now, the way we can tell that it's a linear equation, and let me just kind of give you the format, okay? So forms, this is just forms of the linear equation. And any one of the forms can be put into a different form, okay? But this is just ways that we like to put it, to look at them in order to do different things, okay? So different forms or formats for linear equations in two variables, right? And I'm going to just do that. 2var means in two variables. Okay, the first one that the book likes to give you is what we call generally standard form. Okay? And the standard form is the ABC kind of format, okay? I'm trying to get that on here. There we go. Okay. So let's see. What did I do last time here? I think it's like that. There we go. That's what I did. That helped. Now it's going to stay. Okay. Come back. Nah. All right. So the different forms. Okay, first we'll call this standard form. Looks like this. A x plus by is equal to c. Okay, and of course a, b, and c are just real numbers. Okay, we prefer them to be integers, right? So remember that skill we just got finished looking at where you can clear fractions by using the common denominator or clear decimals by multiplying an exponent of 10, a power of 10. Those are going to be skills that you will consider quite handy as we go along in this. Okay, so keep that in mind. Okay, if you kind of were confused with that skill, let me know. Okay, we can kind of review that together. Okay, all right, so let's see. I'm trying to get this up. There we are. All right, so A, B, and C standard form. Okay, now I'm giving you just the general thing. The next one we're going to go into is called slope-intercept. And I'm going to look a little closer as we go along, but each of these will have its uses, okay? And look, in standard form, just keep in mind, I'm going to write a little, I'm going to write on the right of each thing, I'm going to put a slope formula, okay? So the slope for the standard form, by the way, slope, we use the variable m as in mom. The slope is the slant of the line, the pitch, if you will, the roof pitch. You know, pitch is like how steep or how shallow it is. Okay? And so the slope, m, is the universal variable for slope. So anytime you see m, as in mother, that is slope. Okay? Okay, so just FYI. So the slope, when you have it in standard form, okay, and look, I'm going to put this, prefer A, B, and C to be integers, okay? A, B, C, we want them to be integers. If it's given to you in their fractions or something that's not an integer, clear the fractions or use the multiple of 10 to clear the decimal, and then you can put it in that form where you have the integers, okay? Once you have that, then the slope will be the opposite of A over B. So just whatever your coefficients on X and Y are, put them one over the other. It's negative A over B, the opposite of. We'll look at an example in a minute of each one. Okay, slope-intercept form looks like this. Y is equal to M, there's that M, so slope, all right, plus B, mx plus B. And the name comes from what information you can see right there in the equation, okay? As the equation is, you can readily see the slope, okay? Okay, gotcha. Okay, so there's your slope right there for you, and then B is our y-intercept, so slope-intercept. Next topic is going to be the intercepts. Okay, and of course you don't need me to write down the slope formula, so slope is just, I'm going to put that, slope is just the coefficient of x, just the numerical portion of the x term, Okay, and so, okay, the next one that I'm going to look at with you is important. So I'm going to put this next one in green because these two, you can, of course, we can swap forms easily, and I'll show you how to do that in an example. But this next thing is called point slope form or formula, because this is the formula that will, when you're given certain information, and actually what's in the title, when you're given the information in the point slope formula, you oh, I saw a hand up. Okay, sorry. So point slope, when you're given the point and you're given a slope, you can find the equation of the line that's associated with the point and the slope. Incidentally, if you're given a point and a slope, you can graph the line. So point dash slope, and I'm going to go ahead and label it formula, not just a form. it is a form, a legitimate, like put it in this form, okay, but we can also call it a formula. So, okay, so here's how this works, okay? So the point slope formula looks like this. Okay, given a point on a line, right? X, Y, okay, from a line, and the slope of that line. And the slope, of course, M of that line, of course, the same line. Okay, then the equation of the line in question, right? The equation is given by this. So here's how, when you're asked to write the equation of the line with such and such a point and this slope, here's how you do it. Y minus Y subscript 1 is equal to M slope, right? Open parentheses, then you have X minus X subscript 1. Okay, and let me put my little subscripts right here on this point in the question there. So note, okay, I'm going to highlight in red now. We're given this point, X sub 1, okay? So the subscript of 1 is just telling, it kind of indicates which of these guys in the formula are actually going to become something else, okay? Let me not write this like chicken scratch here, okay? So we're given this point, X1, comma, Y1. It's just a subscript. There might be a time when we have a X2, Y2. Actually, there will be a time soon, like in a minute. Okay, and so these coordinates are going to be substituted in right here at these locations. Okay, so this Y1, we'll get that Y1 from the point, and then the X1 here that's been subtracted will be substituted for this X1 given to you in the coordinate, in the points. Okay, and of course your slope is given to you as well, and you're able to plug that in. So the things I have in red here become numbers. They become numerical. And so let's look at an example. Okay, so here's what these guys are going to look like. Okay, so for example, okay, all right, so given, let me see, all right. Excuse me, sore throat. Okay, so let's say we're given the point, all right, -3, 1, and the slope of 3, okay? Okay, so the slope of 3, comma, give the equation of the line. And I'm not going to tell you what form to put it in just yet, because I'm going to kind of put this in all of the forms if it comes out pretty. I'm going to wait till I get a good one, though. Okay, give the equation of the line. Okay, so here we go. Let's look at what we're given. We're given x1, y1, right? It's -3, 1. That's my x1 and my y1. In other words, if you want to write it out like this, x sub 1 is -3. We're going to put that into that equation, that formula. Y1 is 1. And the slope is given to us as 3, right? Okay? And so these are the values that we're going to put into this formula to give us the equation. So my advice to you, because you're going to have to know this thing, every time you go to plug in to any formula you use, especially from here on out, write the formula out every time. You will memorize this so fast. So I'd like to see that. I'd like to see that y'all write this formula out every time and then plug it in. It gives you a guide. So you go straight down. The y's with and the x without a subscript, like this first one, there's no subscript of 1 or 2 on it. That stays a variable. Okay, that one's going to stay like it is. And so it's the subscripts that get substituted. So now minus y1, so now minus positive 1, I don't need parentheses there, equal to our slope of 3, times x stays the same, minus x sub 1. That means there's a number that's going to be replaced. So look, I open parentheses because anytime, especially when I'm plugging a negative value in, you need parentheses because of your sign rules. Be very careful, sign rules. One little sign error in one of these will just mess you up so bad. So be careful with that. Now y minus 1, and it happens to all of us, you know. Y'all know. Okay. I got you. Let's see. Question. Let's see. Okay, hold on. You guys take a sec and finish this for me, okay? I want to see how you guys can do this. Vivian, you know what? I'm going to take a look at that next. That's a good one, okay? So that'll be next. I'm going to check that out in just a sec. Thank you. Good one. And let's see. This one. Okay, so you should have what in the parentheses? So you should have x plus 3, right? Okay, let me get my pen back up. All right, so we will have, here we go, x plus 3. Okay, so what we have here, guys, as it's written here, this would be our point slope form. Okay, so this is, if you're asked to keep it in whatever form or simplify it into this form, you know, through your algebra skills, this is what we would call our point slope form. Here we call it our formula, right? At the beginning, we call it our formula. But in the context of plugging everything into it, and it now represents one line, a specific line, we call it the point slope form. Okay? All right, so now let's put it into slope-intercept form. Okay, let's practice this one. We're going to put it into slope-intercept. Let's put it here. So what has to happen? What do I need to work towards for this? To put into slope-intercept form, what I need to do is just solve for y. So basically, if you're asked to do slope-intercept form, just get y by itself on one side of the equal sign. That's your goal for that. So let's work on getting this guy alone, okay? So in order to bring that 1 over to the right, I'm going to need to distribute this 3 first, so it'll combine with something, right? So let's do that first. So y minus 1 is equal to, and we'll have 3x plus 9, right? Oh, by the way, yes, I'm grading your midterms. I should have some all grades up within very soon, this early afternoon. Make sure you guys look at the skill gaps, you know, and be careful. And big one, I'm noticing quite a few people who were really good at what they're doing too. Most people, this is a silly error. Make sure you're distributing thoroughly, like 3 to the x, and then actually keep thinking, focusing, and 3 times 3 is 9. Similar distributions on tests I've seen go 3x plus 3 or something like that. So you guys be really careful with that if you could, okay? All right, so now we just need to add the 1 to both sides. Add 1. And so now we have what? Finally, slope-intercept y is equal to 3x plus 10. All right, so now we have slope-intercept, right? Okay. Now what we're going to do next is graph this line, okay? Since I'm kind of running out of time. And then Vivian, I am going to look at that. And that's going to be after this example. So with this example, I'm going to kind of go into the process of graphing the line. Okay, so now let's graph it over here on the right. Let's see, I'm going to make a little space here. So that would be part A. And make a part B now, graph this line. Okay, so let me make some axes. Okay. Okay. So you guys can start doing that. You guys can start getting points. Choose some points carefully. Okay. And like look over it, see if you guys see any anything y'all need to look at with it or any questions about this. Keep putting axes here. I'm going to have to use my mouse for this. Quick. Okay. Oh, it's driving me nuts. Okay, here we go. This will be better. Let me scroll. All right, so I'm going to go down here. Much better. There we go. Isn't that nicer? Okay. So anyway, all right, that's much better. All right, so let's get our axes labeled. We have our x-axis and y-axis, right? Two simple points I can choose, by the way. Oh, I forgot the other form. By the way, quickly, standard form would be this, right? If we subtract 3x from both sides and have negative 3x plus y is equal to 10, this would be our standard form, right? It's where you have x and y on one side. So if you're just trying to get the x and the y on one side and the constant term on the other. So now we have all forms. Okay, as I was starting to say, we can graph this line, okay, by choosing x and y coordinates. What you do, basically, when you're doing this by hand, is you choose x's and then you solve for y. Okay, so we make a little xy chart to keep track of the points that we choose. And now, so let me kind of write this over here, okay? I'm going to write this form of it, this slope-intercept form. Okay, and then right under that, I'm going to write the standard form. I'm not going to really use point-slope form to graph it. That has its own uses. These are the two forms that have a lot of usage for you when you're going to plot, if you're going to graph a line, you know. So negative 3x plus y is equal to 10. Okay, so you guys still with me? Stay a little over if you guys can hang. Can y'all hang out for a little bit while we do this? Y'all gonna be good? Hang tight. And we'll go just a little bit over. We're not gonna be too long, but you guys stick with me, okay? I think you'll like this part. Okay, so now let's just take a look at the slope-intercept form right here. Let's kind of get what information we can. Okay, so what do we know? What is the slope? We know the slope, by the way, would be positive 3, which is given to us in the original question. I know, slope of 3. But if it wasn't, if we only had the slope-intercept form, we would have slope is equal to 3. And look, for now, guys, I'm going to put it over 1, right? We can look at 3 like this. And I'll give you the reason why in a minute. But first, I want to get some other information. Okay, I'm going to show you a couple different ways to get points, okay? Let me see. I need to, minimize that. Okay. All right, so first off, let's talk about intercepts, x and y intercepts, okay? And so let's come down here a little bit and talk about x and y intercept. These are where the line crosses each axis. The x-intercept is where it crosses the x-axis. Y-intercept is where it would cross the y-axis, okay? So how do we get them is this, okay? The x and y intercepts. Let me get my things where I can see it. Okay. All right, to get the x-intercept, this is so easy to remember too. You let the opposite variable equal 0. So to get the x-intercept, boom, let y equal 0 and solve for x. So you'll plug a 0 in for y, wherever the y is. Okay, and I'm going to do that with this example in a minute. To get the y-intercept, and that y-intercept is the one mostly you are going to be asked to get. You are asked to get x-intercept sometimes, but not as often as the y-intercept. To get the y-intercept, you're going to let x equal 0, plug a 0 in for x, and solve for y, right? Okay, so plug a 0 in for the opposite variable, right? And then you'll only have one variable to solve for. Wait, I didn't mean to put 0 there. I meant to just put a period there. Okay, so yeah, you don't, this last part, solve for whatever, you don't even have to really write that. It's just the important thing to remember is to find one, you plug a 0 in for the other, basically. Okay, so let's go back to our example there, okay, and let's just find the two intercepts, okay. So in other words, what I want to do is plug in to get the, let's do x-intercept, we're going to let y equal 0. See, I'm putting a red into the stuff I'm choosing. And that'll be my x-intercept. So find the y-intercept, I'm going to let x equal to 0, right? Okay? And so what you do is plug those in and solve for the other. So let's first find that x-intercept, okay? So let's go down, we're going to take, let's see, I'm going to take the standard form, the negative 3x, and I'm going to come over here and I'm going to do the scratch work down here where I kind of mangled up, wrote ex there, for example. Okay, so the intercepts for negative 3x plus y is equal to 10. The standard form is so much simpler to find the intercepts. Of course, in slope-intercept form, it's there for you in the constant term, but if we look at it, the standard form, okay, so let's find the x-intercept. Okay, we're going to let y equal 0 here. So negative 3x plus, in place of y, I'm going to put a 0, equal to 10, right? Of course, this goes away. Now I have negative 3x is equal to 10, or x will be negative 10 thirds. Okay, so let's kind of go up and just put that in there. So negative 10 thirds. We'll come back to that in a minute. Let's go find that y-intercept. As I have it in standard form there, let's now find the y-intercept, okay? Okay, so the y-intercept, we're going to let x equal to 0, right? We're going to plug a 0 in for x, and we'll solve for y, right? So we'll have negative 3, open a parenthesis for x, plug in the 0, plus y is equal to 10. So now what happens here, this is 0, right? Negative 3 times 0 is 0. Now we just have y is equal to 10, okay? So the values that you come up with, that's going to be the counter coordinate for these guys, right? So we have a 10, we put a 0 in for x, and now we get a 10 out for the y. It's an input and an output. Okay, most of the time you're choosing x's and you're solving for y's, okay? Which brings up independent and dependent. When you plug a value in, okay, this is your independent variable. X doesn't care, right? Because y is always going to depend on what x is, okay? So it's independent. X is independent. So y is dependent. It depends upon whatever you plug in for x. And then to remember that, think about this slope-intercept form. As you have it, y is equal to 3x plus 10. Y depends on what you choose for x. Okay? Input, output. Okay. And so I'm not going to harp on that too much. Let's hurry up and get into this, and I'm going to get it back into y'all questions. Okay, some other things I could do here. Like, I don't want to have to plot negative 10 thirds, right? We know it's 3 1/3. It's a little bit after the 3. I get it. But let's kind of, great, we got the intercept, but let's choose something else now, okay? Let's go back into slope-intercept form, the y is equal to 3x plus 10, and choose a point that would be, you know, handy. Like, let's say, let's choose a negative x value, because if I I have positive 10, right? And let me tell you this, I didn't go that far when I drew the axes, right? I'm serious about this. So you want to learn to choose, as you get experience, you're going to learn to choose wisely. This is what I'm talking about. Y is equal to, let's see, whoops, okay, 3x plus 10. And when you're dealing with fractions, say I had 1/3 x, you would want to choose a multiple of 3, or whatever that denominator is. You'll get used to that, and I'll do more examples as we go along, or put them up or whatever. I'll get you guys used to this. But look, I don't have 10 sketch marks on my graph, right? So I want to choose a negative x value. That'll make this first term negative, right? So let's let x equal to maybe -1 or something like that, okay? -1. All right, so now I chose that. So in my XY chart, I want to put, in red I said was for the ones I'm choosing, I'm going to choose -1, and let's see what I get out in the output for that, okay? And so here's how it goes. We're going to have, whoops, okay, y is equal to 3, open parentheses, plus 10. And so now we want to come back and take this number and plop it into that x value, right? So we'll have -3 plus 10. So 10 minus 3 is 7. I could probably hang with 7, right? That would probably be better. Okay, so let's go ahead and put that in to our chart. Now you could go all day. You could choose points, you choose x's and get y's. The only time you're going to go opposite and choose a y is for the intercept, basically, unless they give you an xy chart where it's kind of staggered and filled in. If that's the case, you plug the one in and get the other. But when you're doing this on your own, mostly you're going to choose x's and solve for y. Okay, so let's plot these things and see what we got here and move on, okay? So let me go to red here. Okay, so if I kept that -10/3, it would be -3 1/3. So here's how I deal with that. I go negative from the origin, right? Left 3, 1, 2, 3, and here's like, break it up into thirds. Here's about where I am there, okay? All right, so approximately that would be where I am. Okay, notice y is 0, so 0 up and down. This is my y-intercept. Okay, so this is the point, -10/3, comma 0. Okay, all right, so now 0, 10, 0 left to right, up 10. Let me show y'all a trick. This is kind of cool. Okay, something you can do is, and I'm going to show you this just quickly. Let's kind of do this. I'm going to put this back in a sec, but don't erase anything you've drawn. But you see we had 1, 2, 3, 4, right? You can scale your axes however you need to. Let's say I had 100, like an y-intercept of 400 or something. I can make this 100, 200, 300, 400 if I need to. Just make sure you have everything drawn, quote unquote, to scale. Okay, so you can scale things how you need to. So we would like to maybe count by twos, you know, maybe this could be 2, 2, 4, 6, 8, 10, so that we could fit the 10. You see what I'm getting at? So however you need to scale, you know, your drawing so that you can fit your graphs on there, you know, you can do that. So let me kind of put this back how it was with the first point. Okay, so back to where we were. But what I'm going to do is just leave it like this and deal with it for now, since I already started. This is 1, 2. We're going to use each line for a unit. So 0 left to right, positive 10 is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's way up here, right? Okay. By the way, so we're going to say 0, 10. Way up there by the XY chart. That's okay. The next, -1, 7. Let's see where that ends up, right? So from the origin, 1 to the left, and then 1, 2, 3, 4, 5, 6, 7. We end up here. Just so your points are falling on a line, it looks like it. How many points do we need to create a direction for a line? We only need 2, right? So we only need 2, but what you're going to find a lot of algebra books ask you to do is to take 3. And on tests and things, you're going to see me on my exams and all, I'm going to ask you to plot at least 3. If I'm asking you to use an XY chart, I'm asking for at least 3 because it gives you a chance to check your direction. Let's say I did this last point and it kind of ended up somewhere over here. Then I would know I need to go look for an error in my work because it's a linear equation, right? It's a line. Because the x, let me draw the line in, by the way, while I'm talking too much. Because the x variable, the highest exponent you see in this equation is 1, right? In other words, there's no, you don't see it, there's no pictured exponent, right? In other words, it's understood to be 1. It's just x, period. No squares or cubes, right? In other words, the exponent is 1. This is a linear equation. If you had an x squared or an x cubed or anything else, anything higher than a 1 on your x for the exponent, then you're going into something that's not a straight line anymore. We're not in Kansas anymore, Toto. So we want to walk the straight line, right, in this section, right? So x to the first power. So notice, go back to the formats that we wrote earlier, and remember, it's x to the 1 power. There's no squares or cubes or anything yet. Okay, so there's our line, by the way, for this. All right, let me move on to your questions. I think I kind of made my points on this. I got that. Oh, the slope. Really quickly, I can get one more point on this line by using my slope. I can think of my slope as rise over run, and let me come write this underneath here. Okay, slope can be thought of as rise over run. So we're going to use slope, using slope to get points or to plot. Here's how, and I'm going straight to your question afterwards, Vivian, okay, I promise you. Okay, so to plot points, we can think of it as rise over run. Remember, the slope is the slant, right? And so if there's my area here and I have a line that's pitched like this, so to speak, okay? All right. To get from one point to the next, I rose, let's say if this is real, I would go rise this many and run that many, right? If I go up 2 and run 1, right, that means rise over run. So watch the slope, okay? We can think of it as rise or fall over run, which is left to right. Rise is up and down, and run is left to right. So I want to go from point A, let's call this A, and let's call this B. To go from point A to B, I am taking how many paces? My Pirates map tells me to go north 2 paces, and then to go east 1 pace, right? And so this is, my slope for this would be positive 2 over 1, right? Here's 2, and this is just 1. So we know the slope for whatever this line is to be 2. Okay? You can also, to get to the point that's in the other direction, just so it would simplify back to being a positive number, since we know it's positive here. Let me show you this. An equivalent form of 2 over 1, this is a cool trick. Wake up, listen to this. It would be negative 2 over negative 1. Notice the 2 negatives would simplify to positive. But watch what happens in the context of rise over run. Let's start at A and go to C and see what happens, okay? So rise, instead of rise, I'm going to fall, right? 2 paces south, right? So that's negative 2, okay? And then negative 1 says go up 1 pace to the west or left. And notice I ended up on the line, okay? So that's a cool way to use your slope, rise over run, to get to another point. Now we know this slope on the equation we just finished working on is 3 over 1, right? Let's take that, let's start from this point let's see, I'm going to get a point with whole numbers. Let's start from the point -1,7, okay? And I want to go down towards the x-axis, like in the graphing area. And so I can't rise 3 and run 1. I'll just get to 0, 10. We can think of 3 over 1 as -3 over -1, right? It's positive slope. We want that to simplify back to positive. So from, and I'm going to turn this to, I'm going to use the black for this, just to kind of give us a different color. So we're going to start here, and we're going to go that way, right? We're trying to anyway. So we want to fall 3, right? So this is rise over run. Rise over run. So from this point, we want to go 3 paces down, right? 1, 2, 3. So from here, I want to take it 1 to the left. 1 to the left. Look where I end up. I ended up on the line. That's good. So what point is this? So we need to identify this point now. Now, identifying a point that's given to you in a graph is kind of like graphing the point, plotting the point. To do that, we want to pretend like we're plotting it, okay? And start from the origin and count till you get even with it, right? We're going to be right here, right? So my x must be, the x coordinate for this point must be left 2 or -2. To get up to the point, how many paces? 1, 2, 3, 4. So this point must be -2, 4. Now, if you're not sure, how can you check? This is a cool part. Just like before, we can still check to see if something is a solution by plugging it in. Let's check it by plugging a -2 in to the slope-intercept form right here. Okay, we're going to check it like this. Y is equal to 3 times -2 plus 10. Well, -6 plus 10, right, is 4. And that is what the y is, right? So it does check. And so -2, 4 is another point on this line. Okay, so that's how you can use your rise over run. Okay, you guys, so let me go to Vivian's thing, the question, okay? Oh, the formula for slope, by the way, slope formula. Let me put this in there real quick, Viv, I promise you I'm going there next. Intercept. What? No, what am I doing there? That's not right. Sorry, slope formula. I'm all nervous about getting to Vivian's example there. Slope formula is this, okay, and it's still rise over run, the difference of our x's over the difference of our the difference of our y's over the difference of our x's. So, okay, so delta means the change, or the change in y over the change in x is going to be y2 minus y1, and this is going to be given, by the way, given 2 points, okay, 2 points, x1, and you label it x1, y1, in other words, that's point 1, okay, and point 2 would be x sub 2, y2. The subscripts merely help you keep track of which point this comes from. Okay, the denominator is a difference in your x's, right? So x2 minus x1. Doesn't really matter which point you label as x1, y1, x2, y2. What matters is whatever direction you subtract your y's in on top is the direction you take it in on the bottom as far as point to point, to where you get your x's from. So if I say y1 minus y2, I better go x1 minus x2, or vice versa. Okay, so this is that formula. And then, of course, you can write rise over run. It's the same thing, if you want to put it all in one thing there. Okay. All right, so let me go here and look at this question for Viv. All right. If an exercise asks for the graph to graph the lines of the equation x plus y equal to 2, for example, do I choose the coordinate x and then calculate y? Okay, so did I just answer your question on that then, I guess? Yes, this will be recorded. You guys will be able to check this out later. So hopefully that rise over run bit will help you guys a lot. I'm going to take that example you just put up there, Viv. I'm going to take x plus y equal to 2. Okay? Let's do this example, you guys. It's a real simple one, but, you know, I just want to give y'all one. I'm going to do that in a sec. I'm going to write it up here. Hold on to this for a sec, guys. And while I'm on the slope formula, we're going to come back to this, okay, this formula. Coming back to. We're just going to graph that in a minute, okay? Okay, so but first let me go ahead and get an example for the slope formula out on the side here, okay? All right, so let me separate it here. Okay, let me get all this stuff out of my way. There you go. So this is my little slope section, that's what I'll say. So here, example. If you're given, oh, hold on a second, the points. Given the points. Okay, here we go. All right. I'm sorry, guys. I'm trying to like get a good example I know is going to work out. And okay, come on. Okay, there we go. Let's say you're given the point. Shoot. Sorry. All right. Y is 6. Okay. 1, 6. Okay. The first coordinate, the point, excuse me, is going to be 1, 6. Given 1, 6, and all right, the next one will be bum, 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 bum. All right, so let's see. 1, 6. I'm trying to give y'all a good one I know is going to work. That's my problem. 1, 6, and then 0, 1. Okay, let's find the slope. Okay, so given the 2 points, 1, 6, and 0, 1, comma, find the slope of the line. Because now it's a line, right? 2 points make a line. Technically, for proof purposes, you only need 2. Okay, so what's going to happen here? Let me get my little red pen out. So we're going to label the first one x1, and then the second one y1, right? Okay, 1, 1. Make sure they're 1s. Okay, the second point will have the 2s, right? 0 will be x2, 1 is going to be y2. Okay, so if I write that out here, okay, let's kind of make sure we got our information right. So 1, 6, and 0, 1 are the points I'm given. And the first point I can label as x1, y1. Second point, x2, y2. Okay? This is the information I'm given. Now I can fill in the slope formula. Okay? And so every time I use a formula, especially in this chapter, we want to write that formula out, right? Okay? So let me do that. y2 minus y1 over x2 minus x1. Hello, Jennifer. Welcome. Okay, so here's how we do this, okay? So now, go ahead and write your fraction bar, and we're going to take them in that order, right? If I go 1 minus 6, I better go 0 minus 1. I can't go 1 minus 0, right? Take it in the same order. That's what those subscripts are helping you to do, so be careful with that. So y2 is 1, right? y1 is 6. x2 is 0. x1 is 1. Okay, guys? And now what we'll do is wrap it up at like 12:30, so we won't be too long. We don't want the video to be too bad for Mrs. G to have to put whatever you call convert. So in the numerator, -6 plus 1 is -5. 0 minus 1 is -1. Okay. By the way, you know, you might want to keep this version, the -5 over the -1, handy in case you have to graph it, which we can do in a little bit. But negative over a negative is going to be +5, right? So you might want to keep positive 5 over positive 1 handy. Let's do this. Let's go ahead and plot this, guys, just to practice what we looked at. Because let me see if are there any other questions, or y'all want me to kind of practice that rise over run thing with y'all? Let me let y'all choose. Y'all want to graph it? What do y'all want to do? I want to go back up to the example. Since we don't have a whole heck of a lot of time left, let's let you guys do. You make the call. Which you guys want to do? Anybody? Bueller? I'm kidding. Anyone? So so what do you guys want? What direction y'all want to go? Y'all want more rise over run practice? Yes. Yes. Okay. That's what I'm wondering. Okay. Cool. You got it. All right, so let's do that. Let's take those 2 points, and let's just kind of do everything we can do with it, okay? So let's make a little area to plot, okay? Let me add a little area down here. Oh, okay. Didn't mean to do that. Oh, no. Okay. Go back. Okay, there it is. That's it. Okay. There we are. Yay. Okay, so now let's go ahead. Draw some axes here, okay? And all right, do that. Get quite enough of an area for us we can really actually work with. Okay, that's good. Okay, and then we will label the axes. I posted some really good videos yesterday, by the way, on the whole all this. And there's a couple of other ones I still want to put up, but one of the guys starts out in the video saying a very well done graph starts with a few things. And he says it so well. It's just real simple. It starts with a pair of axes clearly drawn. It starts with graph paper. By the way, on the site, if you go into Lecture 6, there's a link under the post-lecture discussion with some graph paper that you can print. And one of the pages, by the way, and look, I'll sketch it out. One of the pages is the whole thing is just classic graph paper that you're used to seeing. The other one, though, that says like 6 graphing areas, has like a graphing area. It's like 3 down the side, right? And so it's like if you have 6 problems you want to do, you could do like 6 problems on a page. I have others, too. I have one that just has 4 on a page and 2 on a page. There are websites where you can go make your own and print it out. That's fine. But I thought I'd put those 2 on there for y'all. Anyway, you can go print those or save it onto your computer if you need it. By now, you guys should have plotted the points 1, 6, and 0, 1. So if you've done that correctly, by the way, oh, surprise. By the way, you're supposed to be doing that while I told you guys about the printable graphing paper. No, anytime I go off talking by now, I'm hoping you guys are catching on to that. You should be moving, kind of trying to do some of the work yourself. I hope y'all do. You got to challenge yourself with this. Let's plot in red. We have to go from the origin, always begin in the middle, right, at 0, 0. So to plot 1, 6, right, we're going to plot 1, 6 first. Okay, so let's do, I'm going to make like a little XY chart all the way on the right there just to kind of keep track of the points that we're going to plot. So we're going to plot first 1, 6. Okay, so from the origin, we want to go 1 positive, right, 1 pace up. Okay, so from this origin, 1, oh God, is that right or is that wrong? Is that right or wrong? Hello, that's wrong, right? Are y'all awake? Come on, you guys. I know I love it when y'all correct me. I was supposed to catch it quick. No, we don't go up 1, you guys. We go to the right 1, right? X-axis direction, okay? So 1 to the right, and then we go 6 up, right? Now we go up for the Y coordinate. 4, 5, 6. So 1 to the right, up 6. All right. So now we're going to label that point 1, 6. All right, let's graph 0, 4 now. From the origin, 0 left to right. So nowhere. We haven't moved yet, right? Now we go to, did I say 4? That's a 1. I'm sorry. It's that Y that's creeping me out there. So 1 up, right? All right, so hold on. Let's do like that. There you go. I had to fix it because I keep trying to say it's 4, but 0, 1. So 0 left to right, up 1 pace, right? Pirates map paces. Okay, so what is that, by the way? If x is 0 and it's solved for y, then this is, and it's crossing through the y-axis, that, by the way, is my y-intercept, okay? Now, I want you guys to help me, like, get to another point. Let's use rise over run. I want to get 1 upward. I want to go 1 to, like, towards that first quadrant. And then I'd like to get another point going down into the third quadrant, right? By the way, in case you forgot your quadrants, this is 1, 2, 3, 4, right? So I would like to have a point, in another point in my first quadrant, and one other point that's in the third quadrant. Okay, so for the 2 here, okay? So in other words, let me put a little area here. Well, let me use yellow. You can see so much better with yellow. Let's get 2 other points, okay? For this point that I want to fill in this area with right here in my table. For this one, I want this point to be in the first quadrant. So I'm going to put like a little Roman numeral 1, okay? Q1. That'll be this point. And then for the point after that, I'll call it the green point. So the point after that, I'd like that one to be in the quadrant 3. Okay, so this will be in quadrant 1, 2, 3. Okay, no, don't leave, don't go. Okay, so quickly now, okay, quadrant 1, we could start from the point 0, 1, and you can rise 5, run 1. Maybe you'll get beyond the point we already have, maybe not. But it's good practice. So look, 0, 1. Just to practice, okay? Let me get a light, I'm going to get a small pen here. All right, just get a green. All right, we want to rise 5, run 1, right? From this first point here, rise 5, 1, 2, 3, 4, 5, run 1, positive, right? And so that works, right? Rise 5, run 1. Let's do that again in that same direction. And so let me get rid of that writing right above there. So we'll kind of be able to have our space there. Okay, so you guys try it real quick while I erase this. Okay, so rise 5, run 1. Okay, got it? Rise 5, run 1. And then what you do is mark the point and then go back to the origin and count and figure out what the coordinates are. Okay, so here's how it is, okay? So we're going to, from here, right, from here, rise 5, 1, 2, 3, 4, 5, run 1, end up here. Okay, notice it's falling in line. Now what is this point? How would we have plotted it? Okay, and I have a question coming up, so let me check that out. So you, by the way, real quick, you want to come here and count, right? This even right here, right? So X value would be what? Then Y value would be what? Oh, hey, Jennifer, I'm so glad you stayed. Thank you. I'm glad you stayed. It was a good part coming up. I didn't want anybody to miss it. So now we started to count from the origin, right? Okay, let's see. So to figure out what point is, the X coordinate would be what? Positive 2. And then the Y coordinate would be what? 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. So 2, 11. Okay? So there we have it. Okay, so let me plug that into our chart. We got that. We got the point 2, 11. Okay, Important right here to realize that we have the difference in the y's, difference in the x's. Note in the chart, if points are right, one after the other, look, notice 6 and 1 have a difference of 5. 1, excuse me, yeah, and then 6 and 11 have a difference of 5. You want to make sure they have differences of 5. We don't have them in order here, but you can see what I mean. The x's should have a difference of 1. Because that's my value for the slope, right? The difference in my x's, the denominator is 1. Okay, now let's go through quadrant 3. So we want to start at 0, 1, right? We're going to go back here to this point, 0, 1, and go in the other direction. So how did I do that, right? Let me kind of do this too. So far in the format of our slope, we used what? We said the slope was 5 over 1, right? I'm just kind of moving that over. I'm not changing anything, by the way. Except my pen is not working. My pen's like rebelling because it knows what time it is. So far, we have used positive 5 over positive 1, right, to go up and to the right. Now, if I want to get to quadrant 3, that's down here, right, I need to be able to go down and left. And so doing that requires me to do a sign adjustment. But we want to keep it equivalent, right? We want to make sure it always can go back to what it's supposed to be. It's supposed to be positive 5 for our slope. So a negative over a negative, that works because 2 negatives will give me that positive 5. So only doing this in order to use slope to get to another point. And it's a very handy little trick to use when you're trying to stay in a certain area for a graph, when you're drawing the graph. So start at 0, 1, and let's fall 5 and go left 1. Or as the pirate would say, matey, go south 5 paces, matey. I'm like the most Cajun sounding pirate I know. May go 5 paces to your south. I'm going to get Cajun on y'all. Like 1, 2, 3, 4, 5. And then we're going to go, right, that was this guy, right, negative 5. And now left 1, right, because of negative 1. 1 to the left. And this is where we end up, right? And so is it still falling in our line? Yes. It's kind of falling into that same slope as the other guys. And so look, I'm going to go ahead and draw in the line while you guys get the coordinates. Okay? So whoever types the coordinates into the questions box first gets the magic prize for the day. Okay? All right. So here's my line. You see that? Okay? Okay, we're going to do one more thing after this, and I'm going to have to call it for today. So let's see who put it in there. Good job. Man, y'all are awesome. Yes, you are correct. You are correct. Both of y'all are correct. Negative 1, negative 4. Y'all rock. So cool. All right, negative 1, right? Because we start at the origin, left 1 would be the x coordinate, right? And then 1, 2, 3, 4 down, or negative 4 to get to that one. So that's the point. Negative 1, negative 4. Very good, girls. Okay? So here the XY chart is, this is kind of what we plotted to do this line. By the way, one more thing we can do, given 2 points, we can write the equation of this line. Just quickly, it'll be our last example. Okay? So let's say, what is the equation of this line? Okay, so we'll make this a part B or C, or really whatever part Z, whatever we're on. So what is the equation of this line? Okay, well, we're given 2 points. That's fine. We just need what? Let's write that formula. The point slope formula is this. Y minus Y1 is equal to slope X minus X1. We just need one of those points. And whatever one you use the most handy one. And we need the slope, which we know is 5. So if you're given, you may be given a problem that says given 1, 6, and 0, 1, give the equation of the line. All you do is use your slope formula first, and then choose one of the points in the slope to do what we're about to do in this part. So you're going to see those now. You will see those problems like what I'm talking about right now. And so, okay, so we have slope. Let's see, we have m is 5. Use positive regular version, simplified version of 5 now, right, of slope. So we have that, and just choose one of the points you're given. Let's choose 0, 1. Why not? Okay, make life a little simple, right? 0, 1. Okay, we right off the bat can get rid of one of our variables, right? And by the way, 0, 1 would be x1, y1, right? So you know what to plug in where. Okay, so to plug in, we're going to go y minus y1 is positive 1, right? Equal to our slope of 5, then x minus 0. Love it, right? That just kind of gets rid of that, the work on that side. So all you have is 5x on the right and y minus 1. So let's get into slope-intercept form, and we'll have to add 1 to both sides. Right, cancels here, and we have y is equal to 5x plus 1. And so there you have it. Look, this is our slope-intercept form. If I was just given this equation by itself, right, let me close that thing that's in my way. If I were just given this y is equal to 5x plus 1, I would see that there's my slope of 5 and that the y-intercept is at 0, 1, which it is, right? We know this. Okay, so what you can do, guys, is at the graph where we graphed this, okay, let me kind of get my red pen now, we can go ahead and take this equation we just found, y is equal to 5x plus 1, and now we can label the graph as y is equal to 5x plus 1, right at the end by one of the arrows. You can label it on the top part too, or at the bottom, or whatever, wherever, but generally when we label a line, and actually we would write it a little smaller than I did just there, you can go here, you can say this is y equal to 5x plus 1, right at the tip of the point there, the arrow. Okay? That's what I have for you guys. Are there any other questions for now? As they come up, you guys, feel free to text me or email me questions that you would like an example similar to, like maybe as a video, or even just to post a video that I know of. You know, if I don't have time to do exactly the exercise or the example that we spoke about in a lecture, I definitely will be posting something for you on the YouTube channel. So don't forget, that's a valuable resource for you guys. And once again, I'm sorry, my computer's been giving me so much issues. It's actually getting a little better, and actually have an appointment this afternoon with the office guy, the computer dude. So anyway, no, you're very welcome. All of you guys are very welcome. I'm here for you. I'm about to go do some more midterms, and so they're coming. I think I have most of them done now, posted. I'm going to post lecture 5 afterwards. I know y'all are probably more excited to get the midterm grade. Okay, there's not too much comment on the grades too. It's not giving me any place to write comments on the midterm grades. I'm just letting y'all know this. So if you want comment or a review of any of those problems, you'll have to ask me individually. Okay, guys, have a great day, and don't think too hard. Just practice your math and try to enjoy it. It's always just some puzzles to solve. I'll talk to y'all soon, okay? Bye-bye. Bye-bye now.